All right, so we are going to start talking about similarity. So we're going to start off with similar polygons, okay, and similar polygons. So the definitions to know, first off, this word ratio, hopefully you've heard that before. It's when you're comparing two numbers using division. It's fractions. Fractions are ratios. Fractions are division that has not been done yet. One that you're probably hopefully very comfortable with is slope, right? Rise over run. 3 different ways you're going to see ratios is where they use a colon in between it. They can use the word 2, or they can write it as a fraction 2 over 3. And it might actually look 2 over 3 vertically as well. Okay? So that's how we're going to see them most of the time for this class. We're going to see them as fractions. Okay, so a proportion is an equation. That means it has to have an equal sign with it. Okay, so proportions are equations, and they're stating that two ratios are equal to each other. This is what you just did on the previous page. Those were all proportions where you cross multiplied. Okay, and then when figures are similar, that's where that top part of the congruency symbol comes from. It means similar, that little whoop, okay. And when figures are similar, they have the same shape, but not necessarily the same size. So one is like a blown up version or a shrunken down version of the other one, okay? So very similar to the transformation stuff we were looking at, except the size of those shapes change, okay? So if you've heard of dilation, that would be what we're looking at here. So similarity ratios are what these guys here would be. Your fractions are your ratios that show you how big or how small one is compared to the other one. You're also going to hear the term scale factor. These two things mean the exact same thing, okay? And the big thing here is to make sure that we simplify our fractions, and I will go over those calculator steps again as well. All right, so here's a problem that you might see. The following polygons are similar. State the similarity ratio, then use it to solve for x, okay? So this is where you're going to bust out those colored pencils, okay? And we're looking for which sides correspond to each other. They match up with each other. So this 25 is on the right side of my figure, and this 15 is on the right side of my figure, so they correspond to each other. Then this x corresponds with this 24. So if you want to bust out some different colored pencils or highlighters, this would be the place to do so. When I want to figure out what my similarity ratio is, I have to use the one that has numbers because x doesn't help me with that. So I can look at either 25 compared to 15, or I can do 15 compared with 25. You just have to keep it consistent, okay? So if you want to simplify this in your calculator, 15 over 25 will be easier. You can type in 15 divided by 25 and get a fraction, or get a decimal, and then you're going to hit that second PRB button, and it will turn it into a fraction. Or, since you know you want to simplify, you can type in 15 and then hit that button that has the ABC fraction on it, and then hit the 25 and the equal sign. And on the screen, it's going to show you 15 with a little and then a little 25. And when you hit equals, it should simplify it down to 3 to 5. So make sure that you try that first before you move on. So if you need to pause this video and go get a calculator, please do so. So this turns out to be 3/5. When you do 25 over 15 and you do this process here, it's going to give you a mixed fraction first. It's going to look weird. It's going to have a number and then a weird fraction like this. When it does that, you just have to hit the second button and then that ABC button again, and then it will turn it into a improper fraction, and it should give you 5 out of 3. So before you do anything else, I want you to pause the video. If you haven't done so already, go get a calculator, try these calculator steps, and if you need to ask a friend, please ask a friend, okay? So what matters here is keeping in mind where the big shape versus the little shape is, okay? It's all about lining things up properly. So I have a tendency, and Miss Reisman has a tendency, to always go from left to right. So I always do the shape on the left to the shape on the right. You can always do small shape to big shape if you want to, but you need to find something that's consistent. So if I'm going from the shape on the left to the right, that means I'm doing the big figure over the small figure, okay? So for this guy, I have 5 over 3, big shape to little shape, and it's going to be equal to x over 24, okay? If you make this the 24 on top and the x on the bottom, you're going to get the incorrect answer. So you got to be really, really careful with that. And what's cool about this is you don't have to use the simplified version. You can use this version if it's easier for you. If it asks you for the similarity ratio, I like using it because smaller numbers tend to be a little bit easier to work with. So here we're just going to do a little cross multiplying. So we've got 3x equals 5 times 24. Okay. All right, so 3x equals 5 times 24 should give you 120. And then we can divide both sides by 3, and x will equal 40. And since this is a length, it's 40 units. Okay, so this guy right here, the length of this guy is 40 units. Okay, so there's 2 more example problems on the back of this that we'll walk through. All right, if we go to the back of this page, we're going to match things up again. So 14 is on the left side, 21 is on the left side, x is on the right side, 24 is on the right side, and then you've got an 8 here and you have nothing here. And since I already have my variable of x, this is not helpful to me. So I can just completely ignore it. I only need 4 elements anyways to set up that proportion, right? You only have 4 spots, so you don't need any more than that anyways, okay? So similarity ratio wise, I have to use the purple ones because they're both numbers. X over 24 doesn't help me, okay? So I have, and I'm going to go from my left to my right like I always do. So I'm going to do 14 over 21. So I'm typing in 14. I'm hitting that ABC button, and I'm typing 21, and that should reduce down to 2/3. That is my similarity ratio or my scale factor. And then I'm going to take that 2/3 and I'm going to set it equal to, and I have to go from the left to the right. So I have from my x to my 24. And if it helps, right, my left side is my smaller figure and my right side is my larger figure. So small to large for this one, okay? And then same deal, we're going to do a little cross multiplying. So I have 3x equals 2 times 24. 2 times 24 gives me 48. And then I just need to divide by 3 to get that x equals 16. And again, this is a length, x by itself, so this is units. Okay. Let's look at this last example. So in this one, I have 3 things that match up. I have 20 with 24. I have 40 with 5x plus 3. And I have 35 with 42. I don't need all of those, so I can pick which ones to use. But I have to use, in this case, the purple ones because that has the x involved. Okay, so I know I'm definitely going to use 40 over 5x plus 3. I have to use that one. And then I get to pick which other one I'm going to use, orange or black. And since the orange letters are smaller, I just like using smaller numbers because that makes it easier to me. So 20 over 24, if I reduce that in my calculator with that ABC button, I should get 5 over 6. And this is my small figure to my large figure. So the numbers on the top should have something in common. These two and these two should have something in common, okay? And you know what? Let's do this one. We're okay. So if I do a little cross multiplying here, I'm going to scoot this up so I have space. I'm going to do 5 times all this, and I have to put those in parentheses. It is 5 times that entire expression, which means I'm going to have to distribute. And then I have 6 times 40. So 5 times 5 gives me 25x. 5 times 3 gives me 15. 6 times 40 gives me 240. And then I can subtract 15 from both sides. That knocks out. 25x comes down, equals stays in the same place, and I get 225. I can divide both of those by 25. Knocks that out, and x equals 9. Now in this case, that 9 is not 9 units because this side here is not just x, it's 5x plus 3. So to figure out what that side would be, what that unit would be, we just found out that x is 9. So we're going to use that to our advantage up there. We are going to do 5 times that 9 plus 3, just like we've been doing with a bunch of stuff, right? 5 times 9 gives me 45 plus 3, so this is 48 units. That would be this length of the triangle right here. Okay? So you've got some homework problems to look at. So some of them just have numbers, and they will be more like example 1 and example 2, and then some of them have expressions, so they'll be more like example 3. So just make sure you're using your notes to help you, make sure you're matching things up, and there is an answer key for you, so you can check if the answers are correct. All right, so we've already looked at these a little bit, but just as a nice reminder, the perimeter, right, that word rim right in there, is the length around a figure. This is one-dimensional, okay? Area is the size of that surface, right? And so that is two-dimensional. Those are going to be really, really important. And then we have scale factor, which the other word for that is similarity ratio, just like we were working before. And that is the ratio comparing the sides lengths of the similar figures. Okay, so what we're going to do is we're going to make a ratio to compare the sides, okay, and then we're going to simplify it. So just a nice reminder that scale factor has to be simplified. So we're going to use these things that we've been working on and apply them to perimeter and area. So the scale factor here, we can compare the 9 and the 12, or we can compare the 24 and the 32. Since 9 and 12 are smaller, I'm going to go with those guys. So 9 over 12, which reduces down to 3/4. And what's cool is the scale factor is also one-dimensional since it's a length, just like perimeter. So just kind of keep that in mind. So if I wanted to find the perimeter of these two shapes here, remember, all you got to do is add up the sides, right? So remember that this side here is also 9. Got to have all 4 sides. So I'm just going to add together the 4 sides. And that should give you 66 units. And then if we look at this other one, there's 2 missing sides here. We can fill those in. And we can add those all together. And that should give you 88 units. Okay. And so if we look at the ratio of that, if we take that 66 over 88 and you reduce it, you can use your calculator for it, it turns out to be 3/4. And if you notice, this guy is also 3/4, and they're both one-dimensional, right? Scale factor is one-dimensional, perimeter is one-dimensional, so it should make sense that their ratios both turn out to be the exact same thing. If you can hear the jingling, it's just my dog. wandering around. So, on the flip side of that, we have area, and area is two-dimensional, so something slightly different is going to happen. But let's just do a little reminder. These are rectangles, so we know that the area is just base times height. So we can do 24 times 9, and that is going to give us 216 units squared. And then the bottom one here, same thing, base times height. So we're going to do 32 times 12. And that is going to give us 384 units squared. And you can pause and check those if you need to. Remember, that's the beauty of videos, is that you can pause them and you can check whatever you need to check to make sure it makes sense to you. So if we look at the ratios of these, so if I take 216 and I simplify it with 384, so you can use that ABC button on your calculator. If you have a TI calculator, you're going to hit math, enter, enter. But when you reduce this, you should get 9/16. So if you remember a little bit from learning perfect squares, 3 times 3 is 9, 4 times 4 is 16, which hopefully makes sense because we're taking this 3/4, which is in one dimension, and we're raising it to the second dimension. So we're doing 3 squared, which gives us that 9, and 4 squared, which gives us that 16, because area is two-dimensional, so it's squared. So kind of cool. Pretty neat little patterns going on there. So we're going to look at 2 problems on the back of this, and so you can see how you're going to be presented with problems, and we will go from there. So this should be your first guy. Let me zoom it in a little bit. And we've got, to start us off, it's asking us if RTS is similar to triangle UWV, what would their similarity ratio be? So that's just taking the side lengths, so I've got 16/20, and reducing it down, which gives us 4/5. So 4/5 is our similarity ratio, or our scale factor. Remember, they mean the exact same thing. Okay? And for the perimeter, since it's the same dimensions as the similarity ratio as the side lengths, we can just take that 4/5 and we can compare it to 36/x. So you can do a little bit of cross multiplication goodness here. This is zooming in a little bit so I got some space. So we've got 4 times x equals 5 times 36. So 4x equals 180. And if we divide both sides by 4, we get that our perimeter here, which we've labeled x, is going to be 45 feet. And it's technically feet to the first. We don't normally write that, but if it helps you remember that this one's to the first power and area is to the second power, please do so. Okay, we're going to do the same idea with area, but instead of using 4/5, we need to square both of those, which should give us 4 times 4 is 16, and 5 times 5 is 25. Remember, exponents are just multiplying the same number by itself. And then we're going to set these equal to, we have an area of 48, and then an area of unknown, so that's y. And I've been going left to right for all of these, which is small figure to large figure. And then we're going to do the same thing. We're going to do a little cross multiplying. Get 16y equals 25 times that 48. So 16y will equal 1,200. And then if we divide by that 16, we're going to get that the area is 75 feet squared. So what's cool is the squared that you would put on your units matches what you do to your similarity ratio, just like this guy is to the first power for perimeter. So we didn't have to do anything to this. We're raising it to the first power. So there's kind of some nice connections going on there. Okay? And the next example, the only difference is they didn't give you a picture. And so honestly, the easiest thing to do is to draw yourself a picture. And since you get to draw it, you can make sure everything is nice and lined up, which I fully appreciate. And these are both quadrilaterals. They're boxes of 4. I always like drawing my quadrilaterals a little wonky. And then I've got one that's a slightly different size, right? So I've got, you're going to start in the same part. So if W is here, H has to match up with it. So we're going to go in the same order. That's really important. So W, E, R, T directly around my shape. H, J, K, L directly around my shape. Okay? And then they also told us that from E to R is 2. So from E to R is 2 inches. And from J to K is 18 inches. And those match up, which is really, really nice. Okay? They also told us that the perimeter of WERT, W-E-R-T, so the perimeter here is 21 inches, and the area of HJLK, the area over here is 729 inches squared. So we want to find the missing perimeter and the missing area. Okay, so how we're going to do that is the same exact deal. We're going to look for that scale factor. So we're going to compare the 2 and the 18, which is going to bring us down to 1/9. Okay, and if it doesn't specifically ask for the scale factor, you could just use 2 over 18, and you can just square that value. It's completely going to work. So we've got 1/9. I always like using smaller numbers if I can, and I'm going from left to right. So I'm going to go from 21 to my unknown. So I'm just going to use the letter P for perimeter. But if that is not, you're not a fan of that, you can always use X. And then when I cross multiply, what's awesome is I'm doing 1 times P, so that's just P equals 9 times 21. So my missing perimeter here is 189 inches. Okay. And then for the area, I'm going to take my 1/9 and I'm going to square it. So 1 squared and 9 squared. 1 squared is just 1. 9 squared is 81. And I am setting that equal to my unknown A value. That totally looks like a P. Let's fix that. Boop, 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 boop. Maybe I should use a capital A. Is that better? So we'll do capital A instead there. See, correcting your handwriting is really helpful. And we are going to compare this guy to 729. Okay. So let me give myself a little bit more space here. So we're going to do a little cross multiplying, which will get us 81A equals 729. And then we're going to divide by that 81, and we will get that our missing area should be little tiny, remember this is the smaller figure, should be 9 inches squared. And hopefully that makes a decent amount of sense, because this is saying that the big shape is 9 times as big as the small shape. So 21 compared to 189, that's a pretty big jump. 9 to 729, that's a pretty big jump. That makes sense for this problem, okay? If their scale factors were something like 4/5, we would expect those numbers to be much, much, much closer, okay? So hopefully you're feeling pretty good about that. There is some practice of this. So there are a couple where they give you on page 9 the similarity ratio and the perimeter and area, and they're asking you for the other ratios. So the similarity ratio and the perimeter ratio are going to be exactly the same, and the area ratio is going to be squared of that. So the one thing I want to point out to you is if they give you the area ratio, so if I tell you that the area ratio is 25 to 16, and I want to know what the perimeter ratio is, you're going to have to undo the square. So just keep in mind that's the square root of 25 and the square root of 16. So my actual ratio here would just be 5 to 4. Okay, and if you have questions about that, I just want you to write them down for me, and we will take care of them on Friday when I get back. Also, number 17, 18, 19, and 20 are a little bit more challenging because they started off the problem with area ratios, so you're going to have to do this step, and you'd have to simplify the fractions first. You can't just square root the ones they gave you because they didn't give you the perfect squares, and it's a whole thing. So if you need to skip 17 through 20, that's completely fine. And if you want to write down questions, if you want to try it, I did make an answer key, and the sub does have it, and they are posted on Canvas for you. So feel free to message me with any questions, and I will see you on Friday.